delivering a high-quality product is the hallmark of Japanese manufacturing.
The family will launch with Mitsubishi SpaceJet M90 to be delivered in 2020.
Japan's Mitsubishi has long been known as a first-tier supplier to the aerospace industry, but it took a decision to move one stage further and actually create an aeroplane.
After decades of silence in passenger aircraft manufacturing, Japan is back, and this time, it means business. The Mitsubishi SpaceJet M90 is a full-on comeback backed by national pride, cutting-edge technology, and a mission to change air travel as we know it. But how exactly did Japan bounce back after its aviation dreams were crushed years ago? And what makes the M90 so different from anything else flying today? Join us as we break down the story behind this Japanese plane. Meet the Mitsubishi SpaceJet M90. Back in the 1960s, Japan built its first and only commercial aircraft.
The first Japanese-made passenger airplane in half a century has taken to the skies, the Mitsubishi regional jet.
The YS-11. It was a small twin-engine turboprop designed to serve the country's aviation needs after the Second World War. At first, it looked promising. The YS-11 got off the ground, airlines picked it up, and it even saw some international orders. But soon enough, problems began to surface. The aircraft couldn't keep up with competition from American-made planes, maintenance costs piled up, and its performance didn't meet international expectations. Eventually, Japan had to shut the program down.
Mitsubishi Heavy Industries announced on February 7th that it will terminate its project to develop a passenger jet.
That failure stung, not just for the aviation sector, but for the whole country. It left a kind of scar, a reminder that even with all of Japan's technological skill, some things just couldn't take off. What happened next left Japanese aviation in ruins for several generations. Keep watching because the story is just getting started. For nearly 50 years, Japan kept quiet when it came to building passenger planes. It wasn't that the country didn't have the expertise. Japan had been producing top-tier components for Boeing and Airbus and was deeply involved in parts manufacturing. But designing and flying its own airliner again? That felt like too big of a gamble. Economic slowdowns, shifting political priorities, and a focus on electronics and automotive industries pushed aerospace further down the list.
How can we talk about Japan's economy and not mention robots? Japan is often called the robot capital of the world.
And don't forget that strong global players were already dominating the skies, so the idea of trying again felt too risky. That started to change in the early 2000s, thanks to Mitsubishi Heavy Industries. After building warships, power plants, and fighter jets, Mitsubishi decided it was time for Japan to step back into the game. They weren't aiming to build a jumbo jet or take on Boeing's 787. Instead, they set their sights on a regional jet. In case you've never heard about them, regional jets are the smaller planes you usually see on shorter routes. There was a clear market opportunity, especially in Asia and North America, where regional travel was growing fast, but options were limited. And so, the idea for a new aircraft was born, something that would be lighter, cleaner, more efficient, and proudly Japanese. From the start, the project wasn't just about selling planes, it was about pride. It was about Japan showing the world that it could design, build, and fly its own modern airliner.
Heavy financial losses have forced Mitsubishi Heavy Industries to suspend work on the development of its SpaceJet M90 airliner.
Here's the catch. Japan's goal was to break into the 70 to 90 seat market, where Brazil's Embraer and Canada's Bombardier had been leading for years. Japan saw an opportunity to offer a smarter alternative, an aircraft with better fuel efficiency, lower noise, and a smoother ride. This wasn't just business. It was a national statement. To make this happen, Japan's Ministry of Economy, Trade, and Industry poured serious funding into the project. Billions of yen were funneled into research, development, and production. The government wasn't just backing a product, they were backing a comeback. It was one of the most heavily supported aerospace projects in the country's history, not just financially, but in terms of national will, and the result of this sheer effort will surprise you. When the aircraft was first introduced, it was called the MRJ, the Mitsubishi Regional Jet. It had a clean look, sleek body, and a fresh design. But as the project moved closer to global launch, the team realized the name didn't quite capture the vision, so they changed it to SpaceJet.
Mitsubishi Aircraft is rebranding its MRJ regional airliner family. The 92-seat MRJ 90 will be known as the SpaceJet M90.
The new name aimed to feel futuristic and global, something that would stand out in an international market. It wasn't just about where the plane could fly, but where Japan wanted its technology to go: forward, far, and high. The launch of the SpaceJet stirred something in the country. For many Japanese people, it felt personal. The memory of the YS-11 was still there, but now it was being rewritten. Japan wasn't trying to copy anyone this time. They were bringing something new. There was a clear sense of aviation nationalism, a feeling that this aircraft symbolized more than travel. It represented everything Japan stood for: precision, quality, and ambition. It was a message to the world that Japan was back and had learned from the past. As the aircraft started to take shape, interest poured in. All Nippon Airways was one of the first to support the idea, placing an early order. Soon after, US-based SkyWest showed confidence in the aircraft as well. For a country that hadn't sold a single plane in decades, these early orders were more than just deals. They were validation. The plane hadn't flown yet, but the buzz was real.
So the primary market for regional jets is in the United States. There is also a large market in Europe and emerging markets in Asia.
Headlines around the world started to pick up the story. A new Japanese aircraft was coming, and it promised to change the way regional travel worked. But behind all the excitement was a quiet pressure. Japan couldn't afford another YS-11 situation. Too much had been invested, not just in money, but in national pride. The entire aerospace industry in Japan was watching. So was the public. If the SpaceJet failed, it wouldn't just be a missed business opportunity. It would shake confidence across an entire sector. But if it worked, it could reset the rules of regional air travel and open new doors for Japan's tech future. This is where the story gets interesting. Because while the foundation has been laid, the real power of the SpaceJet comes from what's inside: the parts, the tech, the thinking behind every curve and every engine bolt. Stay with us. That's where we're going next. Inside the Mitsubishi SpaceJet M90. Step inside the SpaceJet M90 and you'll quickly realize it's not just another plane. This aircraft was built to break the old stereotypes around regional flights. Everything, from the materials to the cockpit layout, was rethought to make the experience smoother, cleaner, and more comfortable. And it all starts with what the plane is made of. Unlike older jets that rely heavily on metal, the M90 uses carbon fiber reinforced plastics across key parts of the airframe. These lightweight composites aren't just there for show. They cut down the plane's total weight in a big way, which directly helps save fuel. A lighter jet needs less power to fly, and that means lower costs for airlines and fewer emissions pumped into the sky. The weight savings also allow the plane to carry more passengers or fly longer distances without refueling. The wings are not just light, they're smart. They were designed with efficiency in mind, shaped carefully to cut through air with less resistance. At the tips, the wings curve upward into sleek, blended winglets. Believe it or not, they are not for decorations. They actually reduce drag, which again helps save fuel. Even small tweaks in wing shape can lead to huge benefits over thousands of flights, and the SpaceJet's wings were engineered to make every drop of fuel count. That is not all. Inside the jet's cockpit is a full fly-by-wire system.
Full fly-by-wire system was the Avro Arrow interceptor, which was even controllable from the ground, needing no pilot.
Which means the days of purely mechanical controls are long gone. Everything is run electronically. Pilots send signals through computers rather than cables and pulleys. That might sound complicated, but it actually makes the aircraft safer and more responsive. Fly-by-wire also allows for smoother handling in all weather conditions, since the onboard systems constantly adjust in real time to keep the plane steady. The Japanese also reworked how the cabin handles air pressure. The M90 is built to maintain higher cabin pressure during flight, which might not sound exciting, but it changes how people feel on board. Higher pressure means more oxygen in the air, and that helps passengers feel less tired or dizzy after landing. It's a small change that makes a big difference on those short regional hops, where every bit of comfort matters. And speaking of comfort, the cabin layout flips the usual script on small jets. Normally, regional planes feel tight, like you're being squeezed into a flying tube. But the M90 took a different approach. The cabin is roomier, with wider seats and more headroom than competitors in its class. The windows are bigger too, letting in more light and giving passengers a better view. It's all about making the flight feel less like a quick shuttle and more like a real travel experience. In the cockpit, the upgrade continues. Instead of the usual maze of buttons and knobs, the SpaceJet's cockpit is built around touchscreens. These Rockwell Collins systems give pilots full control through large, colorful displays. Multifunction screens show everything from maps to engine data, and pilots can move through settings with just a few taps. That reduces confusion, shortens training time, and makes the overall flying process more efficient and intuitive. While passengers enjoy a quiet ride, they probably don't realize why. The M90 was built with noise reduction in mind. The engines are placed in a way that pushes noise away from the cabin, and layers of insulation are packed into the fuselage to soak up sound. It's not just about comfort. Remember that lower cabin noise makes communication easier for the crew and helps reduce fatigue for everyone on board. We are about to reveal one of the most innovative tech on board, so keep watching. One of the smartest features is something most people never see. The SpaceJet is loaded with real-time health monitoring systems that keep track of every part of the aircraft while it's flying. If a component starts to wear out or shows signs of failure, the system can alert maintenance crews before anything goes wrong. That means fewer delays, fewer surprises, and a huge boost in safety. Airlines also save money by doing repairs before things break down completely. But what is an aircraft without an engine? The M90 is powered by the Pratt & Whitney PW1200G.
The Mitsubishi Regional Jet, or MRJ. New airframes that celebrated first flights over the past few years. First flights powered by Pratt & Whitney engines with geared turbofan technology.
A geared turbofan engine that's been making headlines for all the right reasons. It uses a special gearbox that lets the fan spin at a different speed than the turbine, which increases efficiency and lowers fuel burn by around 20% compared to older jets in its class. That's a big deal for airlines watching their bottom line and for a planet trying to reduce carbon emissions. And yes, the SpaceJet didn't stop at saving fuel. It was built to meet the strictest global environmental standards. That includes the latest noise and emission rules from the International Civil Aviation Organization. The aircraft passed with flying colors, showing that it's not just modern in design but also responsible in how it flies. For airlines looking to shrink their environmental footprint, the M90 checks all the right boxes. With all this packed inside, the SpaceJet M90 isn't just a regional jet. It's a flying tech showcase. So, how did Japan lull off one of the biggest wonders in modern aviation? What you're about to witness is truly legendary. Stay with us. Building the SpaceJet M90. Building the SpaceJet M90 wasn't just a technical challenge. It was a national ambition taking flight. We mentioned earlier that the Mitsubishi Heavy Industries led the charge. This was a company with a massive footprint in everything from ships to rockets. But building a passenger plane from scratch? That was new territory. Still, Mitsubishi took it on with confidence. They weren't improvising. They were building a system, a structure, and an international team to bring Japan's aviation dream to life. Mitsubishi didn't treat this as a domestic project. They opened their doors to the world, pulling in expertise from global partners who had years of experience in commercial aviation. From the United States to Germany to Canada, engineering specialists worked alongside Japanese teams, helping to develop core systems that would meet the highest international standards. These weren't just contracts X, they were deep collaborations, with teams sharing technical models, testing data, and solutions in real time. The goal was clear: design an aircraft that could hold its own globally, not just in Asia. At the center of the build was a brand new final assembly line in Yokohama. Mitsubishi didn't just reuse an old facility. They constructed a fresh site purpose-built for aircraft manufacturing. This wasn't just about having enough space. According to the project manager, they needed an environment where precision could be the norm. Aircraft manufacturing demands accuracy down to fractions of millimeters, and this plant was designed to meet that level of precision every day. The line balanced automation and human skill, where robots lifted, aligned, and positioned major structures, while trained workers handled the fine work, wire harnesses, and complex installations that needed the human touch. But even the best-built airframe needs a reliable engine, and that's where the partnership with Pratt & Whitney became essential. The two companies worked together on a custom engine, the PW1200G. If you thought you've seen the best, then what you're about to see will leave you speechless. Pratt & Whitney brought deep technical knowledge, but they also adapted their technology to match the M90's needs. This engine wasn't just attached to the aircraft, it was developed to be part of it. Inside the cockpit, the brains of the plane came from Rockwell Collins, a top-tier avionics company based in the United States. They provided the flight control systems, navigation, and display panels that pilots rely on. These systems were smart. They processed real-time data, offered predictive maintenance warnings, and reduced the pilot's workload during routine and emergency scenarios. The M90's cockpit wasn't overloaded with switches and dials. Instead, it featured streamlined glass panel displays designed to keep everything clean and easy to manage. It reflected a modern philosophy. The pilot should have just enough information, clearly presented to make quick, safe decisions. For the outer body and internal structures, Japanese firms Sumitomo and Toray played leading roles. Toray is a global leader in carbon fiber composites.
Toray Industries Incorporated was established in 1926. Since then, to maintain sustainable development as a basic materials manufacturer,
and provided materials that were lightweight yet incredibly strong. These composites helped reduce the overall weight of the aircraft without sacrificing durability or performance. Lighter aircraft burn less fuel and emit less carbon dioxide, which made this contribution critical to the M90's environmental goals. Sumitomo, with its deep history in metallurgy and industrial materials, provided specialized components and ensured that everything met the demanding standards of aerospace quality. To ensure all these systems would perform in the air, wind tunnel testing became a priority. While Japan has its own testing facilities, Mitsubishi turned to top European wind tunnels to push the limits of the design. These facilities allowed engineers to test scale models of the M90 under simulated flight conditions. Adjustments were made to wing shapes, control surfaces, and engine nacelles to reduce drag and improve lift. Wind tunnel testing might not sound dramatic, but it can make the difference between a good aircraft and a great one. Every curve, every surface detail was refined to maximize performance before the plane ever left the ground. And when it was time for the real thing to take off, flight testing moved to Washington State in the United States. This might sound surprising, but the decision was deliberate. The U.S. offers some of the best flight testing infrastructure in the world and, more importantly, access to FAA oversight for eventual certification. The open skies of Washington, with varying weather conditions and ready support facilities, provided the ideal environment for trial flights. Every component, from landing gear to pressurization systems, was tested over thousands of hours of flying. Pilots from Japan and the US worked together, taking notes, pushing limits, and feeding data back to engineers in Japan who refined the design in real time. Japan's National Space Agency, JAXA, also stepped into the process, not with rockets this time, but with advanced simulation tools and aerodynamics modeling. JAXA helped simulate everything from emergency landings to bird strikes, giving Mitsubishi insight into rare but critical scenarios. These simulations reduced risk during live testing and helped Mitsubishi design safer backup systems. It was one of the clearest signs that Japan was treating this aircraft not as a prototype, but as a serious global product built to last and compete. Just as important as the aircraft itself was the team building it. Japan had never built a jet of this scale for the commercial market, which meant a new workforce had to be trained. Mitsubishi launched extensive training programs, partnering with universities, trade schools, and even international organizations. Young engineers learned how to read aerospace blueprints, use advanced design software, and handle delicate aircraft materials. Technicians were trained to meet international quality assurance standards. These weren't just short-term hires. Mitsubishi was building a full aerospace talent pipeline to support not just this jet, but a whole industry that could grow beyond it. So the building of the SpaceJet M90 wasn't only about one airplane. It was about coordination across borders, across disciplines, and across generations. With every part assembled, tested, and improved, the M90 stood as a symbol of what Japan could do when it merged its own craftsmanship with global aviation know-how. And while the aircraft was now complete in form and function, one question remained. Would the world accept this bold new player in the skies? That answer wouldn't come from the engineers, it would come from real-world data. Unfortunately, Japan has decided to pause the mass production of the jet, at least for now. So, the superjet might never get the chance to fly en masse. Thank you for staying with us. What do you think about Japan's decision to pause the M90 production? Share your opinions with us in the comments section. If you enjoyed the video, like, share, and subscribe to our channel. Also, click the following video on your screen, and you will enjoy it.